This video will go over an additional example of logistic regression with the bank loans data in an effort to try to predict the personal loan variable, which is the decision about whether or not a customer of the bank will apply for a personal loan and accept the loan. So we're going to start with the Logistic3Example2 Python notebook, and we'll need the bank loans data and eventually the data called loan applicants. So in this file, we'll go ahead and upload the data. So we did this previously with the other example. Okay. And we've got the data set info and the description. So we discussed that previously. So I'm going to create a new model, different model with different variables than we did in class the last time. So we'll use experience and income as numeric feature variables. And then we'll use dummy variables that represent all the categories that we have for the education variable. And there are 3 categories. So one thing we might want to do is check something like the experience variable, because up here it says it's an integer, but in all likelihood it may have numeric values. So we'll do the data set dot experience and so here are all the values for experience. Not sure what the negative numbers represent. They're really small. But if we look at all of these values, we can see that there are a lot of different values for experience. We could even go ahead and just calculate the mean. And because we see the mean is 20, even though this is an integer, this is clearly not a dummy variable. So we can use this as a numeric variable. We could look at income and also look at the mean. And the income is 73.77. So it's not a dummy variable either. It must have values other than 0 or 1 because the mean is not between 0 or 1. Now, if we look at education, we've looked at this previously, but just keep in mind that we can do the value counts. And there are 3 values for education. So if we want to capture all of those as dummy variables, one option, if we want to capture all 3, is to go ahead and just use the get dummies statement. And then if we go ahead and look at all the columns, we can see now there were 2 object variables, education and state. And now it has split those out into 3 dummy variables each. And notice it's taken away the original education and state variables. Now we're going to use personal loan as a target variable. So this is for convenience, and this really helps once we use make predictions. But we're going to just take the personal loan column out of row 10 and then capture it and then put it back in at the end. And so we see that that's what happens. We've got personal loan now at the end. Okay, so we were going to use experience and income as numeric variables. So we're just going to make a list called X numeric that has those 2 columns. And then we'll build our X range by using that list. The Y variable is personal loan, and that's the last column in the data set, so we'll use -1 to represent that. Now what we want to do is scale these numeric variables, and sometimes I get in Jupyter Notebook rounding of values, but the decimal values are there just displaying a rounding value. Now, we'll update this comment. What we wanted to do was go ahead and use all values of education as potential variables to predict personal loans. Now, there are 3 values, but all we have to do is use 2 dummy variables. So we'll just use the first 2, 10 and 11. In logistic regression, we just need, if we have 3 values for a variable, we just need 2 dummies. Now we've already scaled the other x variables, so we just need to add these dummy variables to the other x range. So this will create a new column, and then we'll add, it's actually 2 columns. So then we add those new columns to the x range. And axis equals 1 refers to columns. So we're ready now to split this into the training and test set. Again, right now, Jupyter Notebook's displaying rounded values, but the decimal values exist. And I think it sometimes does this if I've had Jupyter Notebook open for a while and running things. So you may or may not see this. And so here's our confusion matrix and accuracy score. So seems like a high level of accuracy, 96%, but keep in mind that there was about a 90-10 split in the original data. 90% 0, no personal loan, 1%, 10% 1, which is the personal loan. So we can calculate our false positive rate. False positives are row 0, but column 1. Okay, they're predicted to be positive, but they really are not positive. So we'll do CM01. And if we want the percentage, we can just divide by the number of values in the test set. So 0.008. False negatives are values predicted as negative right here, but the true value is positive. So that is row 1, column 0. Or about 3%. Now, the precision is related to all of the positive values that we're identifying. Some are true, some are false. So let's calculate that. The true positives are these, predicted positive, and they really are positive. So that's row 1, column 1. Again, row 1, column 1. And then the false positives were right here. So that's 0.875 is precision. All right, recall. True positives, again, are 1, 1. And the false the false negatives are right here, CM, row 1, column 0. The use of these precision and recall versus accuracy is going to get a lot of other discussion as we go forward with classification models. So we will get to that. The F1 score is a measurement that attempts to balance these, and it's 2 times the precision times the recall, but then divided by the precision plus the recall. So it's about 0.744. Another way to look at the trade-off between true positives and false positives is to look at something called the ROC curve. And so it requires calculating the predicted probabilities for all the test set values. That's done with this statement. Okay. And then the next 2 statements create this ROC curve. And what it shows is that, we would like for true positives to be very high, but we'd like false positives to be very low. So the more this curve goes up and then goes horizontally, the better off it is. If the curve is, the extreme case would be that it'd be a diagonal line where we're completely trading off true positives for false positives. But that's not the case here. Here it seems to be a pretty good model in terms of eliminating, some of the false positives and capturing true positives. Now, this statement here will create all the predicted probabilities for all of the test set. So that is another example of logistic regression, and the next video will discuss predicting the value in the loan applicant.